combine both of them to deal and tackle different types of numericals, right? So if you want to become an expert, or if you want to get comfortable with electrodynamics, the first thing which you should do is you should know about the vector calculus. Because if you have some understanding of vector calculus, then uh, it is you will be like, if you are comfortable with vector calculus, you will be able to solve many numericals in electrodynamics. So I will be not going into details, but I will give you some exposure. Then we can. Okay, now are you familiar with Cartesian coordinates? Yes or no?
Yes, sir.
So in Cartesian coordinate, we have x, y, and z, right? So any point P will be denoted by x, y, and z. So this is Cartesian coordinate. And there is another coordinate called spherical coordinates. See, why you should, okay, suppose if this is x, y, and z, and suppose there is a point P, then in spherical coordinate, we define this point P by using three variables, that is r, theta, and phi. Yes? So can someone tell me what is r and what is theta and what is phi? Suppose this is the origin, and if I draw a line here, then the angle made by this vector with the z-axis, that is what we call as a theta, right? And the magnitude of this vector is what we call as the r. And if I take a projection of this point on the xy plane, then this angle is what we call as phi. So this is r, theta, and phi. But here you can express x as r sine theta cos phi, and you can express y as r sine theta sine phi. And what about z? Anyone?
R cos theta.
R cos theta. Good. But see, here the important point which I want to emphasize is the increment vector, dl vector. This is very important because most of the electrostatic problem can be solved easily if you know the incremental vector, dl vector. Dl vector means, suppose you have a vector here L, and suppose there is some increment here, dl vector. So this increment, how can you express in spherical coordinate? That is very important because most of the electrostatic problem, numericals, you can solve it if you have a proper understanding of this expression of incremental vector. So the incremental vector, can someone tell me how do we write the incremental vector? One is dr. dr means along the r cap direction, then r d theta, theta cap, plus r sine theta d phi, phi cap. So this expression is very important. We are going to use this expression most of the time. Now, this means in the r cap direction, the change is denoted by dr. And in the theta cap direction, the change is denoted by r d theta. And in the phi cap direction, it is denoted by r sine d phi. Right. Now, let us take a simple example and let us learn how we can use this concept to evaluate the integral, right? So can someone tell me what is the area of a sphere? Can someone tell me what is area of a sphere? Surface area. Yes. 4 pi. Yes.
R square.
R square. Okay. Now this 4 pi r square, let us try to derive using spherical coordinate.
Sir, excuse
Right.
me.
Yes.
I'm not seeing your screen, sir.
What about others? Can you see my screen?
No, sir. Visible. No, sir. Not visible.
Oh, is it like that? Okay, let me.
Good morning, sir.
Yes, sir.
Can you hear me?
Yeah, I can hear you, sir.
I think there is some issue. There was something due to some. I will just allow you this automatically. Everybody got screen sharing off. So I will just within 1 minute. I will just allow this.
Okay.
Yeah.
Their participant
Sorry
initially
for
were.
the disturbance. Yeah.
Okay.
I don't know
Okay,
why
fine.
this.
So initially, were you able to see my screen? Did
Yes, sir. Just now it was cut off.
Okay, I'm unsharing it and I'll share the screen again. Somnath sir, you have made me as an attendee and you are the organizer. I think because of that. Sir, I think we
This
can hear.
I don't know. I cannot change in this meeting.
Fine,
I
fine,
don't
sir.
know why this who can present.
Okay.
So I have now for time being allowed everyone. I'll just
Okay.
try
Okay,
once.
sir.
There is some problem going on in this MS Teams. It hung and then.
Fine, sir. We will
Okay,
proceed it like this.
I'll just.
So now
Or do
you
you
have
want to try something or?
Yeah,
Sir,
you
we
can
will-
share now, sir. You can share. You can share.
Okay, sir. Fine. Okay, the screen is visible to everyone.
Yes, sir. Yes,
Yeah, it's visible.
Yes.
Sir.
Okay. So, okay, now, Mr. Channaram, I think now you will be able to record. Please record the session. Okay, fine. So, surface area of a sphere is 4 pi r square. We know this formula, right? But the approach which I'm going to teach you, that approach is more important than this formula, right? So the approach is, okay, now let us have a 3D axis like this. Right. So you have a sphere here. I'll draw a sphere like this. Okay. Now, suppose you are on the surface of a sphere. Suppose you are on the surface of a sphere. And if you move throughout the surface, which quantity changes and which quantity remains constant?
Sir, radius will be remaining constant and the other two quantities will be changing.
R remains constant. Right. And since we are talking about area, we at least need two variables. Suppose if we talk about volume, then we need three variables. If we talk about 1D line, we need one variable. So here R is constant and the other two variables are theta and phi. Okay. And in spherical coordinate, remember R can go from 0 to infinity. And what about theta? Yes. What about theta? Theta can go from 0
Zero.
to
2
There is some background noise. Okay, tell me, R theta can go from
0 to pi
0 to pi, and phi can go from 0
0
to 2 pi. You should know this because, okay, now, so what we know is theta and phi are variables. So for theta, can you see this? The change in theta is given by r d theta, and the change in phi is given by r sine theta d phi, right? But here r is constant. So what we will have is r d theta, and this one we can have capital R sine theta d theta d phi. So the surface element ds is equal to r square sine theta d theta d phi. Are you able to get this?
Yes, sir.
Right, because see, in two, I think you can get this one. Okay, now the whole area will be given by integration of ds. So when we do the integration, it will be r square sine theta d theta d phi. So we can break this down. R square, we can take it outside. Sine theta, this will be double integral. D theta, theta will go from 0 to pi, and this one will go from 0 to 2 pi. Now, if you integrate this one, if you integrate this, you will get what? 4 pi r square. Okay? Yes? Are you able to follow this?
Yes, sir.
So, whenever you apply a spherical, let me write on the, whenever you apply, let me choose a different color. So, whenever you apply spherical coordinate, what you have to do is just identify whether it is a 2D integration or a 3D integration. If it is 3D, then your volume element, you can write r square sine square theta, sorry, sine theta, dr, d theta, and d phi. Fine. If it is a 2D, you identify what are the two independent variables. Right. Once you identify, you use this formula and you can write. For example, suppose, do you want to do more example on this one? Shall I explain with one more example? Or is it fine? Yes? Hello?
Sir, we need another example, sir.
Okay, fine.
Okay, fine.
We will do it one more example. Suppose in 3 dimension, there is a x, y, z, and let us say that there is a circle here. Yes, there is a circle on the xy plane. So you want to find out area of the circle. Area of the circle. What is the area of the circle?
Yes, sir.
What? Pi r square, right? Yes. Area of a circle is pi r square, right? Hello.
Yes, sir.
Yes, sir.
So now let us try to apply this spherical coordinate. spherical coordinate to find out the, see, they will not ask what is, they will not ask to find out the area of a circle, but whatever approach I'm using here, that will be useful. Find out the area. So area is a 2D or 3D?
2D.
2D. So I need two variables. Right? Now, in spherical coordinate, there is r, there is theta, and there is phi. So in this area, which is there in the xy plane, so if you take any point here, let's say I'm taking point P, which is the quantity, which is a variable which is constant? Is it r? Is r constant? If you take any point on the area, is the r variable constant?
No, sir.
No, because see, if I take a point here, r is changing. So we got one variable, that is r. What about theta?
Theta is constant, sir.
Theta is constant because theta is the angle with the z axis, right? Theta is the angle with the z axis. So since it is in xy plane, what is the value of theta here?
90 degree.
90
90
degree.
degree. Very good. So this is 90 degree. Why there is an echo? Okay. What about phi? Phi is changing?
Yes, sir.
Phi is variable,
Yes.
right? Okay, so now we have got two variables. So for r, we write it dr, and for phi, we write it r sine theta d phi. But theta is already constant, so we will write r d phi. Fine. So this surface element will be equal to this multiplied by this, right? This multiplied by this. So we will get r dr d phi. That is the surface element on this circle. Now, if I want to find out the total area, I have to integrate this ds. That is integration from 0 to r, integration from 0 to what? 2 pi. Because phi varies from 0 to 2 pi. So r dr d phi. So if you try to integrate this, r dr 0 to 2 pi and d phi. So for this r, you will get r squared by 2. And for this phi, you'll get 2 pi. So if you cancel it out, you'll get pi r squared. Fine. Have you understood this?
Yes, sir. Yes, sir.
Okay, so this is the approach. Means whatever means if you want to apply spherical coordinate, identify whether it is a 3D integral or a 2D integral or a 1D integral. Then you identify which are the variables which is constant and which is changing. Once you get that one, you let me go back to the previous slide and let me use the pointer here. So once you identify which is the variable, then you use this formula, then you integrate, right? Now, the same logic can be applied for cylindrical coordinate. Cylindrical coordinates. So in cylindrical coordinate, we use, some people write r phi z and some people write s phi z, but both the notation are same. The only thing is you have to identify which one is r. Suppose you have a cylinder like this. Okay. Suppose you have a cylinder like this. Okay. Now this point is what they are calling as Z, and this radius is what they are calling as R. And if this is X, and this is what they are calling as phi. Okay. Are you able to follow this? Yes or no?
Yes, sir.
Now, similar to spherical coordinate, you should know that dl is, this can be written as dr r cap plus r. Remember, this r is different from the spherical coordinate r. R d phi cap plus dz z cap. That means along the r direction, the change is denoted by dr. Along the phi direction, it is r dr. Along the z direction, it is dz. This is what you have to focus on. Right? Fine? Okay. Now, let's go and try to solve one numerical here. I hope everyone have understood something from spherical coordinate and cylindrical coordinate, how to implement those coordinates for finding out the area or volume, right? So, okay, before I go, can someone tell me how to calculate the volume of a sphere? Volume of a sphere is nothing but the integration of the volume element. So here, since it is 3-dimension, you can write everything r square triple integral r square sine theta dr d theta d phi. If you try to integrate this, then you'll get 0 to r square dr, integration of 0 to 2 pi. 0 to 2 pi is for what? Pi. Then integration of 0 to pi for sine theta d theta. If you integrate this, you'll get 4/3 pi r cube. That is the volume of a sphere. Okay, now let us solve some numericals. Okay, this was asked in GATE. Okay, before this, okay, I'll go back. I need to explain one more topic. Now, suppose, I think I need to create one more blank slide because once again, I think this will be sufficient. Okay, now we have learned about spherical coordinate and cylindrical coordinate. Now, okay, now let us come to electrostatics. Now, suppose if you have a point charge, okay, if you have a point charge, what is the expression of the potential at a distance r? Can someone tell me? What is the potential at a distance r if the charge is q? Yes? 1 by 4 pi epsilon naught q by r. Right. So that means, can I say V is proportional to 1 by r?
Yes, sir.
So whenever you know the expression, the dependence of V, then the E will be always 1 power greater like this. Yes? Do you know
Okay,
the
sir.
reason why? Do you know why it is 1 power extra?
Because it's
Because we need to
differentiate.
differentiate.
Because electric field is given by the gradient of V. So when you differentiate, you'll get 1 power extra. Now, suppose I have a dipole. plus Q minus Q. Now, dipole, the dependence is 1 by r square. Do you know the formula for this? It is 1 by 4 pi epsilon naught P by r square. It is P cos theta actually. It's the dipole moment. So from here you can say that it is 1 by r square. So can someone tell me what about the electric field dependence? 1 by r square or 1 by r cube?
1 by r cube.
1 by r cube. Very good. Now, suppose I have a system like this. I have one plus Q here, minus Q here, plus Q here, minus Q here. Okay. This question was asked in, I think, NET 2023 or 2014 or something. Okay, now you tell me 1 by R what? Yes?
R power 5.
1 by?
R power 5, sir.
R to the power?
5, sir.
5. Okay, I have one answer, that is 1 by R to the power 5. What about others? Okay, I'll give you some option. 1 to the power R to the power 4, R to the power 3. Option A, option B, option C. Which one is correct?
Option B.
A, B, C. Which one is correct? Okay. Kindly mute your mic. Okay, now. Please mute your mic. Technical team, you can mute the mic of that participant. Okay, now see, I will draw another example here, and you'll see something very interesting here. This system also has 4 charges, plus Q, minus Q, plus Q, minus Q. Can you see the difference between the top one and the below one?
Top one, 2 dipole, bottom quarter pole.
See, yeah, in this example, the dipole moment is what is the direction of the dipole moment? From positive to negative, right? From negative to positive. But see here, in example 1, the dipole moment, one is pointing in this direction, the other one is pointing in this direction. Then you can have one more dipole here in this direction and one more dipole in this direction. So if you see this 4 arrow, will the net dipole moment be 0? Yes or no? If you see this 4 blue arrow, will the net dipole moment be 0?
No, sir.
That means in this configuration, dipole moment will dominate. So for dipole moment, what is the dependence? E. What is the E dependence?
1 by r cube.
Yeah, so the answer for this is E is directly proportional to 1 by r cube. And V will be 1 by r square. Right. Now let us come back to the second example here.
Sir, one doubt, sir.
Yes.
Sir, we can think of about this case you just now discussed, no, sir. We could think of the plus q as single charge and minus q as single total big minus q charge. So it will also
No,
be
see, the problem is, no, there is some, this will come from the dipole expansion actually. There is one integration which we have to solve, then only the answer will come. There's that assumption, whether it is valid or not, that will depend on the point where here, whenever a question is asked, they will ask like this: find the electric field dependence at R, where R is much greater than D, the separation, right? So you are saying that if we take it very far away, then plus q will act like a single charge, right?
yes, sir.
And minus q will act as a single charge. Then you are saying that it will behave like a dipole. Yes.
Oh, yes, sir. Because only we are getting like this formula. I'm asking.
But what about the second case? Let's see the second case. In that case, it should behave like no charge at all, right? Because plus q minus q 0, minus q plus q 0, right?
Yes, sir.
Yeah, there is some deeper physics in that concept. So if you want to know further, you please refer to electrodynamics by Griffith. Okay.
Okay, sir.
Because there is this Dirac delta concept will come into picture, and you have to deal with the dipole expansion. Okay, now let us see this example. One is pointing in this direction, other one is pointing in this direction. And here one is pointing in this direction and other one is pointing in this direction. So try to see the 4 red arrows. And their distance are same, their magnitude are same. So what will be the net dipole moment?
0.
0. That means this is actually a quadrupole. So in quadrupole, you can increase the power by 1. That is, V is directly proportional to R cube and E is directly proportional to R to the power 4. Fine. Okay. Yes. Now, there is one, suppose you have some arbitrary charge whose density is rho, and suppose at a point R, if you want to find out the potential at the point R, I will repeat it again. There is some charge distribution and you want to find the potential at point P, which is at a distance R. Then this potential, if you do the formula, if you try to calculate the formula, then this will come like this: 1 by R integration rho d tau plus 1 by R square integration rho cos theta d tau plus 1 by R cube integration. Have you seen this formula before? Yes. And this formula will go on. Now, all of you, please try to listen this carefully, because most of the time you can expect one question from this formula, either in gate or net. Means the frequency of question asked from this concept is very high. So this is the dipole expansion. We call it the dipole expansion. Now, let us try to break it down. The first term, the first term is a contribution from monopole. The second term is the dipole. And the third term is the quadrupole. Fine. I think I wrote the quadrupole spelling wrong. Okay, quadrupole, right? So now this term denotes the net charge, right? Okay, now this term denotes the dipole moment, right? And this is what you have to understand. Now I will break it down one by one. Now, in this example, can you see this example? The first one. What is the net charge here?
Q.
Q. That means this term will be non-zero or zero?
Non-zero.
Non-zero. And you can see that each term is multiplied by 1. See, the first one is multiplied by 1 by r. The second term is 1 by r squared. The third term is 1 by r cubed. That means the contribution is decreasing or increasing from each consecutive terms.
Decreasing.
Decreasing. Now, since this has a net charge of q, the leading order term will be from the first term or the second term or the third term?
First term.
First term.
First term.
And what is the power? What is the power here? See here, 1 by
R.
1 by r, right? Yes or no?
Yes, sir.
Yes.
And that is why here we are seeing that V is 1 by r. Can you get it now? Yes?
Yes, sir. Yes.
Okay, now let us take the second example. What is the net charge here?
0.
0. So the first term will be 0? Yes or no?
Yes, sir.
So what is the leading order term? 1 by r or 1 by r squared or 1 by r cubed?
1 by r square.
And you can see here it is 1 by r squared. Similarly, for this quadrupole, what is the for these two example, what is the net charge? 0.
0.
But here, by using symmetry argument, we found that in this case the net dipole moment is 0. So what is the leading order term here? 1 by
R cube.
r cube, right? So yeah, fine. Okay, now I will explain one more concept, then we can straight away go to numericals. Okay. What is, you know this example, right? If there is a plus q and minus q separated by distance d, then the dipole moment is given by, the magnitude is given by q into d. Yes or no?
Yes, sir.
And the direction is from negative to positive. Yes? Okay, now tell me the dipole moment of this. Yeah, this. Anyone? Tell me the dipole moment of this example.
There is only one charge.
Yeah, there is only one charge. I can even ask like this. If you want two charges, I'll give you two charges. Minus q, minus a0, then plus q, a0. I can ask what is the dipole moment of this. I can even make it three charges also. Maybe four. Yeah. So, have you seen such type of questions before? Now, here comes the solution. Dipole moment of discrete charges. Discrete charges. If you want to find out the dipole moment of discrete charges, you have to use this formula. Summation of qi ri vector. This is the formula. But there is a twist here. Whenever a discrete charges are given and you are asked to find out the dipole moment, the first thing which you have to do is, step one, calculate the net charge. If net charge is 0, then your frame of reference, you can, okay, I will write it like this. If net charge is 0, then you can choose any frame of reference. Because whenever the net charge is 0, the dipole moment is independent of the frame of reference. Now, if the net charge is not 0, then in the question it will be mentioned with respect to which frame of reference you want to calculate. So, are you able to follow this?
Yes, sir.
So in the first example, I have to specify, or in the question it will be specified with respect to what? Because the net charge here is not 0. So I'll say dipole moment with respect to the origin. Can you tell me what is the dipole moment?
QA.
What about the direction? I cap. Yes or no? Just see this formula. In the formula, it is r vector, not the magnitude of r. So you have to consider the vector. not not only the magnitude. Okay, what about in the second question? Do I need to specify some frame of reference?
No, sir.
Now let us solve this one in two ways. Let's see. Let us try to confirm whether it is correct or not. First, I will take this origin as the frame of reference. Second, I will take this as the frame of reference. I'll call this one as case A and case B. Let's see whether the dipole moment are equal or not. Okay, for case A, what is the dipole moment? A into Q I cap, yes or no? Then minus A into minus Q into I cap. Yes? Hello?
Yes, sir.
Yeah, please respond. Otherwise, it is just like I'm teaching to my laptop screen. So what
Sir,
will be the dipole moment?
sir, one doubt, sir.
Yeah, please.
In the first case, how did you choose the direction, sir, to be positive x-axis in positive I sense? How did you choose that?
See, from the origin, I have to see towards that charge, right? Q. What is this vector? What is this vector? AI
R.
cap, right?
Yes, sir. Why it is not the other way around? I'm asking, sir.
No. You are calculating, see the formula. Ri. Ri is the position of Qi from the origin, right? From the frame of reference.
Yes, sir.
Now, can you understand?
Yes, sir. Yes, sir. I got it.
Okay. Okay, now let us come back to A. What is the answer here?
Two AQ I cap.
2AQi cap. That is, we are calculating the dipole moment with respect to the origin, right?
Yes, sir.
Now, in the second case, let us take the position of this. In the second case, let us take this position as the frame of reference. Okay? And let's see whether it gives the same dipole moment or not. So, P is equal to 0 into Q I cap plus minus 2A into minus Q I cap. Yes or no?
Yes, sir.
So what is the answer? 2AQ I cap. Yes, both are giving the same answer, no? So this confirms that if the net charge is 0, you can take any as your reference point. Okay, now this one, can you calculate? What is the net charge here?
0.
0. So you
0.
can calculate with respect to this point or this point or this point or this point or this point. The answer will be same. All right.
Okay, sir.
Okay, I think we have done enough this one. Let us go to numerical. Now, see, please read this question. Then I will come back to the solution. The question is saying that there is a insulating sphere. Okay, there is a sphere having some distribution rho, and you are asked to find the electric field at R. But here they're asking the leading order, right? Electric field at a distance, not R. I think it's D. There is some D vector here. Then electric field at a D, they're asking. And they're asking the dependence, right? So, okay. But electric field, remember this. whenever you try to solve problems on electrodynamics, it is always better to solve the potential first, then you go for the vector electric field, because potential is a scalar. Scalar means we have to deal with only one quantity. But if you try to solve electric field, it's a vector. Vector means we have to deal with three components, right? So now, so in the V expression, if I remember correctly, I wrote something like this. 1 by R rho d tau plus 1 by R square, then cos theta rho d tau, and some terms like this, right? Now, the first thing which you have to do is you check this term first. This term. How you will check? What type of coordinate system can you use here? Can you use spherical coordinate?
Yes, sir.
So spherical coordinate, what is d tau here? R square. Can someone tell me? R square.
Sin theta.
Sin theta. dr d theta d phi. Right. Yes. So if I try to integrate rho d tau, then you can substitute the expression of rho, that is rho naught a square minus r square cos theta r square sin theta dr d theta d phi. So yeah, then what you can do now? Hello?
We can integrate it, sir.
Yeah, you can integrate it. But you know, like, see, no need to integrate everything. Sometimes, can you integrate only this theta part? Sin theta, cos theta, d theta, and theta goes from 0 to
Pi.
pi. So if you integrate this, you'll get 0. So that means what? The net charge is what?
0.
0. The net charge is 0. So this term will be 0. Now you have to check this integration. That is rho naught a square minus r square cos square theta, then r square. Sorry,
Cos cube.
Cos cube or square?
Square, sir. Square. Sorry.
Yeah. Now you have to integrate this one, and you can check, right? You have to integrate, and this one will come to be non-zero. So tell me, so V is what? Directly proportional to 1 by what?
R square.
R square. So E will be directly proportional to?
1 by R cube.
So the correct answer is?
C. Option C.
Very good. Very good. And see, now by using the dipole expansion spherical coordinate, you are able to solve this, right? So we move on to the next question. Any doubt? Please. Because in the coming questions, we will be dealing such type of numericals, maybe somewhat similar.
Sir, one doubt.
So yeah, please.
Sir, how to integrate cos square theta sin theta? Is there any trick, sir?
Sorry, how to?
Integrate cos square theta sin theta dt.
Okay, how to integrate cos square theta sin theta, right?
Yes, sir.
No, that is mathematics, right? You please find out how to integrate that one. But remember this, most of the numericals, no, most of the NetGet numericals, they give it in such a way that dipole, the net charge remains 0, and they confine mainly to dipole moment. Quadrupole, if it is continuous charge distribution, not discrete charge, they confine to dipole moment. But if it is discrete charge, they sometimes go to quadrupole moment. So you can get some idea on that. Okay, next. Shall we move on to next question? Okay. This one I will not do it now. Maybe at the end I can do, because this is a bit lengthy. Okay. Shall we do this?
Yes, sir.
Okay, please read the question. A charge distribution has a charge density given by this. For this charge distribution, the electric field at 2x naught is given by. Now, okay. So, how we will solve this? Anyone? They are asking what? Electric field or electric potential?
Electric field, sir.
So, which one should I go? Shall I go for electric field directly, or shall I go for electric potential?
Electric potential, sir.
Electric potential. So if you want to go for electric potential, you use that formula, 1 by 4 pi epsilon naught integration of 1 by, sorry, by r integration to rho d tau plus 1 by r squared rho cos theta d tau and so on. Right. Now see, you should be happy that the rho is Dirac delta function. So integration will be easy, right? So now let us try to find out this rho d tau. So if I substitute, then it will be q, then it will be Dirac delta function of x minus x naught minus delta x plus x naught d tau. Yes or no? Yes.
Yes, sir.
Now, what about the limit of integration? See, whatever I take, here one charge is at x naught and the other charge is at minus x naught, right? Yes or no? Yes.
Yes, sir.
Yes, yes, sir.
So, okay. Now, if I do this integration, okay, let me just break it down. Q integration of Dirac delta x minus x naught d tau minus x plus x naught d tau. So what is the answer of this integration? This is a normal Dirac delta function, right? Yes or no? Yes.
Yes, sir.
So can I say the answer will be 0 here? Yes or no?
How, sir?
What is that Dirac delta function, that expression, no, minus infinity to plus infinity of, what is this integration? 1, right? Yes or no?
Yes, sir.
Yes, sir.
Now, okay, so that means there is no contribution from this term. So this term, there is no contribution. Okay, now the next part, right? What is the next part? Okay, now here what we will do is, instead of actually this term, this whole term, this is the dipole moment. This is the dipole moment, right? And do you remember the formula which I gave for discrete charges? It is equal to summation of xi, sorry,
Ri.
qi, ri, right? So this one you can write it like this: integration of ri rho d tau. You can even write it like this. Yes, fine. Because see, what is this? This is qi only, right? Yes or no?
Yes, sir.
So integration of, since it is one dimension, instead of ri, means I'm trying to calculate p, the dipole moment. So instead of r, I'll write x prime rho theta. Yes or no? Yes.
Yes, sir.
Now, if I do this integration, it will look something like this: x minus x naught d tau. Sorry, this one will be dx here, because since it is one dimension, plus x bar delta x plus x naught dx. So what will this give?
X naught.
X naught. What about this one?
Minus X naught, sir.
Okay, this one is minus, right? This one is minus. Okay, so minus x naught. Because see, this one is minus, I brought it plus. So the answer is 2x naught into q. Fine. Is this fine?
Yes, sir.
Okay, now we are almost here. We are almost here. Now, so V is equal to 1 by 4 pi epsilon naught P by x square. Do you know this formula? It is actually P cos theta, but here theta is 0 because the coordinate here is 2x naught 0 0. So this is on the x-axis. So we can write 1 by 4 pi epsilon naught P by x square. Yes or no? So now
Yes,
you can substitute the value of P, that is 2x naught by q divided by x square. Now you have got the potential now. So from the potential, if I want to find electric, what is the formula? Electric field will be given by minus the derivative of x, x cap. Yes or no? Yes. So if I differentiate, what will be my answer? Minus 1 by 4 pi. Okay, once again. 1 by 4 pi epsilon naught 2x naught cube x cube x cap. Yes or no? This is the electric field. Yes. But in the question, it is asked that you find the electric field. You find the electric field at 2x naught 0 0. So what you have to do is you have to substitute this x with x naught. Yes or no? Are you not able to follow this?
Sir, in electric field, we are missing a factor of 2, I'm thinking so.
In electric field, what?
There should be a factor of 2 multiplying it, sir.
2. Okay. Yeah. Okay. One more 2 factors should be there, right? Yeah, it's one more 2 factor will be there. So can I write here 2? Is it fine?
Yes, sir. Okay.
Okay, now if you okay, so 2, 2, 4 cancel. So if I substitute the electric field for the point 2 x naught 0 0, then the answer will be x naught q x vector pi epsilon naught, then 8 x naught cube. So this cube cancels square. So minus q by 8 pi epsilon naught x cube square x cap. Which one is matching? None of the options are matching.
Yes, sir. None is matching.
Then there might be some printing mistake or something. Okay. Oh, this one should match 8, 16. Yeah. Okay, but fine. At least you know the approach how to tackle this one, right? Yeah, I'm getting lesser and lesser response as time goes by. Why? Is it very difficult?
Sir, can you please recap this question quickly once?
Okay. So you are given a Dirac delta function. No, sorry, you are given a charge distribution. You are told to find the electric field at this point, right? So what we did was we used the dipole expansion formula. First, we calculate the net charge and we found out that the net charge is 0. So since the net charge is 0, we are going for the dipole term. So for the dipole term, first we are calculating the dipole moment. So to the dipole moment, this is the discrete formula and this is the continuous formula. So since it is one dimension, we are replacing it by x. Then with this row, we are calculating the dipole moment. Then we found out that this is the dipole moment. Then we substitute the dipole moment in the expression of the electric potential. We got the electric potential. Then from this electric potential, we derive the electric field. Okay?
Okay, thank you, sir.
Yeah. Please solve this one. I hope you can solve this. It was asked in GATE 2019. So what is the first thing which you have to do? Whenever a system of discrete charge is given, what is the first thing which you have to do? Yes. Hello.
Sir, we
Sir,
have
we
to
should find
see
the
the
Net
electric
charge.
potential.
No, you have to check the net charge. Whenever a system of discrete charges are given, you have to check the net charge. So what is the net charge here? I think this is minus. Yeah, this is minus. What is the net charge here?
0.
0. Is it 0? Yes. Is it 0 or what?
Yes, sir.
So if it is 0, okay, let's see, minus q by 2, minus q by 2 plus q. So it's 0. So that means what next what we have to check? The question is asking the electric dipole moment. So since the net charge is equal to 0, the dipole moment will be independent of the frame of reference. Yes or no?
Yes, sir.
That means you can choose either this point, this point, this point, any point you can choose. So now for simplicity, let us choose the origin. So with respect to this origin, please tell me the dipole moment one by one. Yes. What is the formula?
Minus q by 2 into
Summation
g
Qi Ri.
qi r cap.
Okay, tell me now. Minus q by 2 into
d
d
j cap.
j cap. Okay, then
minus q by 2 minus d j cap.
minus q by 2 minus d j cap. Then
q into d k cap.
very good. So I think if I see the j cap, it will be minus qd by 2 plus qd by 2, and this becomes qd k cap. So this one will cancel out. So the net dipole moment is qd k cap. Done. Yes.
Yes, sir.
Yes.
But the question is asking what? Electric dipole potential. Yes or no?
Yes, sir.
Yes, sir.
Now, do you remember this? See, if they ask for dipole moment, this is the answer, but they are asking for V. And do you remember the formula for dipole?
P
Yeah, means it is P cos theta, but I'm writing the actual formula. P cos theta by R squared. Yes or no? Yes.
yes, sir.
So, because see, why I'm writing cos theta? Because P is in K direction. And in the question itself, they have given this as theta. Can you see this theta?
Yes, sir.
This theta, they have already given the angle between the R vector and the Z vector. It's theta. So that's why the theta is coming here. So your final answer is? Your final answer is V is equal to 1 by 4 pi epsilon naught q d cos theta by R squared. This is your final answer. Because see, P is in P is in K direction. And the actual formula is like this. And R direction is here, K direction is here. The angle between these two is theta. So I'm putting cos theta. So this was asked in GATE 2019. Any doubts?
Sir, no doubt.
Yeah, tell me.
How a system of three charges will be called as a dipole?
Sorry?
Sir, a system of three charges, how it is called as a dipole? No?
See, what you have learned before, you used to think that, okay, this is dipole, right? Yes or no?
Yes, sir.
Yeah, this is what you normally refer as a dipole, right? But whether it is a real dipole or means whether it is an ideal dipole or not, that is like we have. Okay, let me try to explain in a different way so that you can understand. Suppose there is some charge distribution, whether it is discrete or continuous, right? And if you want to find out the potential at a point P, when you try to find out this expression, then we can see that it is an infinite series. It is an infinite series. The system which you are calling as a dipole, that is a kind of an approximate dipole. Remember this. Hello?
Okay, sir.
That is an approximate dipole. If you want further reading on this, please refer to the dipole expansion concept. Sorry, not dipole expansion, multipole expansion of electric potential. Please refer that topic. It's not dipole expansion, it's multipole expansion. I think I wrote dipole expansion somewhere. I should have written. Yeah, this is multipole expansion, not dipole expansion. Here I have written dipole, but it should be multipole. Okay, shall we move on to next question?
Sir, one doubt.
Yeah.
Sir, you have written this formula in the blue color P dot the formula of voltage P dot R cap.
Not voltage, it's potential.
Yes, sir, potential. When we put the value of dipole moment P vector, then we have to, sir, calculate the dot product of K cap and R cap.
Yes.
Sir, so which of these two formula is more suitable, more accurate for solving?
No, both the formula are the same. No. This
Sir,
is the general formula. This is the general formula, right? But for this case, we can write it like this. This is more general.
Sir, we put P, the value of P in this, in the lefter one. Then how do we calculate K cap dot R cap?
Yeah. K cap dot R cap is nothing but cos theta, right?
Okay, sir. Okay, sir.
Any more doubt? Okay, so we move on to next question.
Yes, sir.
This was yeah, this is very interesting. An electric dipole is placed at the origin. Yeah, this was asked in NET 2018. Read the question once. An electric dipole. Okay. An electric dipole is placed in the origin And what is the direction of the dipole? Yes.
Along
What is
X.
direction?
I
Along I. So can I write it like this? P. Is it fine? Is this okay?
yes, sir.
Yes, sir.
Yeah. Yeah. And it's okay. And there are two charges. One plus Q at LB and one here minus Q at L minus B. Fine. Then they're asking to find the electrostatic potential at the point L by 20. Have you understood the question? They're asking to find the potential. Let us call this point as A. They're asking to find the potential at point A. Yes. Have you understood the question?
Yes, sir.
Yes, sir.
Okay. Now, this is very simple. I will call this system as 1. I'll call this one as 2. I'll call this one as 3. So the V at A will be a contribution of V1, V2, and V3. I can just add it because electrostatic potential is a scalar quantity, right? So I can simply add it. Now, what is V2? I'll start, yeah, V2. Can someone tell me? It's a point charge, right? Yes. You know the formula, right? A point charge Q placed at a distance R, the potential is given by 1 by 4 pi epsilon naught Q by R. You know this formula, right?
Yes, sir.
So for the plus 2 plus Q, what is the V2? 1 by 4 pi epsilon naught, then
Q divided by
Q divided by
B square plus L by 2 whole square. Square root of B square plus 2 whole square.
B square plus L by 2 whole square. Very
B
good.
square, sir.
Okay. What about V3?
Minus 1 by 4 pi epsilon naught.
Minus 1 by 4 pi epsilon naught. Yes.
Q by
Q by.
square root of D square plus L by 2 whole square.
Okay. So we have got V2 and V3. We are left with V1. Okay. So V1, you know the formula, right? What is that formula? We just used in our previous question.
1 by 4 pi epsilon
1
naught
by 4 pi epsilon naught P into cos theta by
R square.
R square. So you substitute now 1 by 4 pi epsilon naught. What is cos theta? What is P? P here, magnitude of P?
QB.
B.
QB. And what is theta?
0 degree. Okay, 1 minute.
0. Cos 0.
degree.
So, and what is R square?
L by 2 the whole square.
Very good. So now we have got V1, V2, V3. So the net potential you can just sum up. That's it. Yes? Any doubt?
No, sir.
Before we end up, shall we take up one more question?
Sir,
Anyone
excuse me, sir.
interested? Yeah.
Sir, in this question, the net potential at the point A will only depend on V1, right? No, sir.
Oh, electric Do you remember in your school days, you must have solved some numerical like this. There is one Q1, there is one Q2, there is some Q3. The potential at this point is a sum of what? V1, V2, V3, right? Have you studied that one?
Yes, sir. Yes, sir.
It's a scalar. If it is electric field, then you have to take into account the vector direction. It's a scalar, right?
Okay, sir.
So I have one system here, one system here, one system here. So the net potential is a simple scalar sum.
Okay, if we add means V2 and V3 will be cancelling, no, sir. From that point of view, I was asking, sir.
Based on symmetry.
Yes, sir. Yes, sir.
Yeah, that's
Plus
fine.
plus,
That's
sir.
fine. That's correct. That's correct. Yeah, from symmetry point of view, because since it is equal. Yeah, it is the charges are equal and opposite, and the distance are same. Yeah, it will cancel out. Okay, fine. I think it's already time. So I have some 4 to 5 more questions, but maybe later on we can discuss again. Okay,